There are special cases in limits. Uh, Sometimes when you are trying to compute a limit, you may encounter 0 over 0 or infinity over infinity, which are undefined. So, and in such case, we use a method like factorization or L'Hopital rules in finding the actual limit. So we try to do some manipulation in order to find the limit. So evaluating limit by factorization. So uh, in this case, let's start with evaluating the limit directly and see. If you want to evaluate this limit, wherever we have x, we just subtract 0. So this will be 2 times 0 divided by 0 square plus 3 times 0. 2 times 0 will give us 0. 0 square will give us 0 plus 3 times 0 will give us 0. 0, 0 plus 0 is just 0. So we have 0 over 0. So this is a special case of limits. So if we have this kind of problem, then we use a factorization method in order to find the actual limit. How do we use factorization? So let me take this. Lim x tends to 0, 2x over x squared plus 3x. Then we look at for something that is common in this denominator, that we have 2 terms here. And if you look at, we have x in each of the term. So then I take x out, then I divide x squared divided by x. This will give us x, and I say 3x divided by x. X will go with x, so we'll just have 3. And if you look at it, x times x will give you x squared. X times 3 will give you back 3x. Then we have x here, we have x here. Sorry, I forget to put the limit x tends to 0. We have x here, we have x here. So I can say this x cancel this x. So it goes into the x one time. So we'll just have 1 here, 2 times 1. So we'll just be left with lim x tends to 0, 2 times 1 over x plus 3. And this 2 times 1 is just 2. So I can just write 2 here. So 2 over x plus 3. Then now I can just apply the limit. So it will be, if I apply limit here, wherever I have this x, I should replace it with 0 here, since we say x approaches 0. So then I will have a 2 divided by, here instead of x, 0 plus 3. So the limit is 2 over 3. Here is another example. Let's start by evaluating it directly. So we have the limit of x tends to 2 here. So we have 2 square minus wherever we have x, we substitute it with 2 since x is approaching 2. So this x becomes 2 minus 5. Instead of this x, we write 2 plus 6 over, instead of this x, we write 2 minus 2. So here will be 4 minus 5 times 2, 10 plus 6 over 2 minus 2, which is 0. Here 4 minus 10 is minus 6 plus 6 over 0. And minus 6 plus 6 is 0 divided by 0. So we have this case, therefore you have to use a special case. So here we want to use a factorization method. So how do? We look at this 2 times, this is the smallest term, so we have to factorize this one with x squared. Then let's just remember that in order to factorize this, we have to look, let me write it again. We have to find the terms that if you multiply them, we get 6. If we add them, we get 5. So if you multiply, we get 6. If you add them, we get minus 5. So, and this terms are 2 and 3 give us 6, but we need negative 2 plus 3 will give us 5, but we need a negative 5, so we can say minus 2 times minus 3. So if we get this, then we can just say x squared minus 5x plus 6 is just equal to x minus 2. Here we have minus 3 minus 3. So we just x minus the first term and x then the second term. We add the second term here. So then we just substitute this factorization, and this is what we call factorization. So we just substitute it back here. So we'll have the limit of x tends to 2 instead of this, or let me just even write it over x minus 2. This is just the same as the limit of x tends to 2. So instead of this one, I will write the factorization x minus 2, x minus 3 divided by x minus 2. So, and if you look at here, you have x minus 2 here, we have x minus 2 here. So this x minus 2 goes in here one time. So we'll just be left with the limit of x tends to 2, 1 times x minus 3, and that's just x minus 3. Yeah, x minus 3. That's all what we have left. And we to take the limit wherever we have this x, since x is approaching 2, wherever we have this x, we substitute with 2. So we'll have 2 minus 3, and this is minus 1. Here we have another example for evaluating limits by factorization. So let's substitute the values we have here. Limit x tends to minus 3 of this. So wherever, since x is tending to minus 3, wherever we have this, we substitute x, we substitute with minus 3. So all these x, we should replace them with minus 3. So we'll just have a minus 3 square minus 9 over minus 3 plus 3. And minus 3 square is just minus 3 times minus 3, which is 9 minus 9 divided by minus 3 plus 3 is 0. So this will be 0 divided by 0. So, and this is undefined, so we have to use so this is undefined, so we have to use the special case of for this is a special case, so we have to use factorization. So I will just say the limit of x tends to minus 3 of so here I think we have to factorize x squared minus 9 here, and so we have the limit of x squared minus 9 over x plus 3. So, and whenever you want to factorize something, you see x squared minus something, just a constant, try to see if you can get square of this. What will you raise to power 2 to give you 9? And I think that is 3. So x minus this, so this is just x squared minus 3 squared over x plus 3. And whenever you have this, you can always write it x minus 3. Whenever you have x squared minus something square, you can always write it x plus that value, bracket x minus that value. So here we have 3, we can write it as x plus 3, x minus 3, then this divided by x plus 3. So here we can see we have x plus 3 here, we have x plus 3 here, and we have factorized this. So this x plus 3 will go with this x. I will enter into this x, goes into this x plus 3 one time. So we have 1 times x plus 3, which is just x. So sorry, 1 times x minus 3, which is just x minus 3. So we'll just be left with lim x tends to minus 3 of x minus 3. And to compute this limit, we want wherever we have, since x is approaching minus 3, we want to, wherever we have this x, we should replace it with minus 3. So we'll just say, instead of this x, then we write minus 3 minus 3, and this is minus 6. Now we will evaluate this limit. So it's a limit at x approaches 4 of this function 4 minus x divided by x squared minus 16. So so since x is approaching 4, let's just wherever we have this x, we should replace it by 4. So 4 minus, instead of this x, we write 4 divided by x squared, then it should be 4 squared minus 16. So 4 minus 4, this is 0. 4 squared is 16 minus 16. So we have 0, 16 divided by minus 16 is 0. So we have 0 over 0, and this is undefined. So since we have the limit is undefined, then we should use a factorization to evaluate the limit in this case. So let's look at the denominator. The denominator is x squared minus 16, and we can factorize this. Then we should look at which number should we take the square of it to get 16, and this is that number should be 4 square. So we have x squared minus 4 square. 4 square is the same as 16. And this, whenever you have a number, x squared minus some number square, you can easily write it as x minus that number, x plus that number, or x plus that number, x minus that number. So x plus 4, x minus 4. So then I can then we just substitute this factorization into this function. So we have limit x approaches 4 of 4 minus x divided by, instead of x squared minus 16, and this we can write it limit of x approaches 4 minus x divided by instead of this x squared minus 16, we should substitute this factorization, x plus 4 x minus 4. So if you look at here, we have this these things look similar, this 4 minus x and x minus 4, but they are kind of here the x is negative, here x is positive, here 4 is positive, here is negative. So we can kind of do something. This one we can kind of factor out the minus out here. So you have the limit of x tends to 4. I can factor out minus here, or I can arrange it as minus x plus 4. So minus x first, then I will write plus 4 next, over x plus 4 x minus 4. And this is just the limit of x approaches 4. I can factor out the minus, so this will be minus. Here I will have x, because this is plus, so I must have minus here, minus 4, x plus 4, x minus 4. So I kind of have x minus 4 here as I need. So here x minus 4 will go into x minus 4 once. So we'll have a 1 minus the limit of x tends to approaches 4. Of here we'll have minus 1 over x plus 4. Now we can easily substitute the limit. So wherever we have x, here we should replace it with 4. So we'll have a minus 1. We have minus 1 here divided by x. Sorry, instead of x we have 4 plus 4. So we'll have minus 1 over 8.